Well, guys, just when I thought that I thought I had the GoPro 8 figured out with the audio problem, but obviously I've updated the camera, I've updated the firmware in it, I've went through all the settings. Obviously, there's something wrong with the sound, the audio on the camera, so I'm probably gonna have to go back to using the GoPro 7 because it just keeps fading in and out, in and out. I made this video here and started editing it, and it's still doing the same thing. So anyway, yeah, I haven't made a video in a while, to be completely honest with you. It's just been kind of a YouTube vacation. It's been kind of nice for a week, not just coming home and relaxing and not having to spend 2 or 3 hours editing and producing a video. So sorry about that, but I just sometimes you just kind of burn out. So a little update as to what's going on. I actually was explaining that while I was making this clip here. This is the 3208 here. We've got all the head gasket stuff. We've got the heads in the back of the truck there, and all the parts cleaned up. Got the block cleaned up, ready to install the stuff. But little update as to what I was doing this week. I tore the got a actually one of the YouTube viewers brought down a Bobcat S205 with the Kubota V2403 engine in it, and that Kubota engine was really he had previously had the Bobcat dealer, I think, come over and they did a compression check on it and had low compression. Anyways, it was really running bad. It was smoking really bad. Well, what happened is number 2 injector overfueled, and it scuffed the piston up really bad. The head of the piston was scuffed up real bad. The crown didn't look too bad, but or not the crown, the skirt. The skirt didn't look too bad, but the crown was scuffed up pretty bad. So the bore wasn't really hurt real bad, but it kind of wore that about from the top of the stroke there to about the middle. It kind of wore the cross hatches out of it. So I thought, I'd be safer off. I'll just send it to the machine shop and let those guys check it out, because on those Kubotas you can buy I think it's a 0.5 millimeters, like 20 thousandths over is the only thing you can buy pistons for that to have it bored. So if I need that bored, I'll just buy the oversized kit and put 20 over pistons, or you can actually bore it and put sleeves in it. They do offer sleeves that you can put back in it as well and put standard size pistons in it. So I just wanted to let those guys check it out at the machine shop so we could make sure that we're doing it right the first time. So the other thing that I've had quite a few service calls. Nothing real important, but I've just been trying to get all the stuff caught up. There's a couple guys that it's called what's it called? Fixing It with the Long Brothers. They've got a bus I need to get over there, and I need to get going on that. That's going to be coming up real shortly here. I'm actually finally starting to get kind of caught up on this backlog of stuff that I've had going on. But the biggest problem I've had here lately has been the good old Duramax. So the Duramax, the 2008 Duramax, had a water leak on the cooler adapter flange. So to be completely honest with you, I think I'm actually explaining that right now, how that works, as I can see my hand motions there. But the way that thing works, okay, so there's the rear cover. It was really hard to even see where it was leaking. I couldn't really tell. I couldn't tell whether it was coming. There's 2 O-rings on the back of that flywheel housing, and then there's 2 holes in the head, and the water goes actually through a channel that's in the rear cover and goes over to the oil cooler, to an oil cooler adapter. And the way it was coming down, and it's so tight in there you can't see anything, I wasn't really certain that it wasn't leaking from one of those O-rings and running down on top of the cooler adapter flange. And, gravity. So I ended up trying to figure out how to get that rear flywheel housing off. Is quite a chore. The way it's bolted together, so what I wound up doing, thinking the rear cover was leaking, I wanted to make sure I got the leak fixed. So what I did is I ended up pulling the front differential and the tie rods and all that stuff out of it, and then I could get the oil pan. And I pulled the front differential out. Then I could get that thing has an upper and lower oil pan to it. So I pulled all that stuff out so I could get the pan out, upper and lower oil pan out. So I pulled those out, and then I could unbolt, because that rear cover, I think the upper oil pan is bolted to the flywheel housing. So I removed all that stuff, got it out of there, resealed it, put it back together, and so I had it sitting there and I found out what was leaking. It wasn't the rear cover, it was actually the gasket where the oil cooler adapter flange uh, seals up to the flywheel housing. That's what was leaking. You could see it. So, lesson learned there. The next one I do, I'll probably just pull the oil cooler. I'll probably just pull the oil cooler off to access that cooler adapter flange on that Duramax. This is an LMM Duramax 08. So I got it all resealed and got water in. I didn't put the transmission in yet. I had the transmission rebuilt, but I didn't want to put it in yet till I poured antifreeze in it to make sure I didn't have a leak. So I poured water in it. It was dripping just a little bit on me, and I kind of made a pretty good mistake there. That cooler adapter flange has got two studs in the flywheel housing with a nut on there, and then there's two bolts where it goes horizontal and bolts to the oil cooler itself. Well, what I should have done is loosened up the bolts on the oil cooler end where it mounted there, and then on the stud end on the flywheel housing, tighten those and torque those down, and then tighten the oil cooler end back up. So I didn't do that. I just decided to snug the ones up there on the studs a little bit up, and what I did is it didn't have any give, see? It squished that gasket, and that flange, it tweaked it too much and it cracked it. So I had to order an adapter flange, and I can't charge it's my fault. Now that I knew that it was leaking there and it wasn't leaking from the rear cover because I couldn't tell where it was leaking at. I ended up buying seals and everything for the oil cooler, and I didn't, I can't charge for any of that or any of the time to do that either. So I explained all this to my customer because to be honest with you, when I first got into this thing, we got underneath this thing and kept pressurizing the cooling system and could not figure out where the water was coming from. It's just so tight in there, I couldn't tell whether it was coming off the cooler adapter flange or if it was coming from the flywheel housing or coming from above that. It was really hard to tell, to be honest with you. So, anyways, that being said, I got the new part. It took 10 days to get that part. It had to be coming from the factory. I called GM and they didn't have one. I had to get it coming from the factory. So, ended up waiting 10 days, put all that back together, got it mounted, and the way you do that is you put that cooler adapter flange and mount it up to your oil cooler after you get the cooler off. Okay, and the way you get that cooler off is pull the studs where the water neck. There's a pipe that goes from the outlet side of the water pump on the front of the engine, and it goes up to your oil cooler. Take the nuts off on the 2-bolt flange on the water pump end, then take external torques, pull the studs out of it, and then you can drop that flange down, and then you can pull that pipe forward, and that way you can unbolt the oil cooler and the cooler adapter flange and pull it off. I didn't even completely remove it. I just let it down far enough to where I could get the cooler adapter flange that I cracked and replace it with the new one and the new seals. I put 2 new seals, O-rings on the nipples on the oil cooler where it slides into the block. And then I remounted it all, but I left everything loose. I left everything on the oil cooler, got all the bolts in it started, left them loose, and then I left the studs loose and left the 2 bolts where the oil cooler adapter mounts to the oil cooler loose. And the first thing I did is I tightened up the stud nuts where the flywheel housing is. I torqued them to 15 foot-pounds, and then I tightened up the 2 bolts where the cooler adapter mounts to the oil cooler and pulled in, and that pulled that oil cooler in flat and flush against that oil cooler adapter flange to make it seal up. And then I bolted the oil cooler up solid to the engine block and then put the adapter flange on. So I finally got the leak fixed. Well, that was just part of the problem. So then got the transmission in it, and then I went and started this pickup. And he told me the other day that he says, you know, something I forgot to tell you is this thing's got a bunch of regen problems, because he said last 4 or 5 days before I brought it into you, he says it didn't want to hardly go, and it kept saying clean exhaust filter and check engine light was on. So I fired it up after I got the transmission in it, and first thing that pops up, I go into the engine codes, and it has an exhaust gas temperature sensor. I get in the data stream, I read it, and it says 1870 degrees, 1873 degrees Fahrenheit. So I knew right away that that EGT sensor either had a broken wire or it was just open circuited, because that's going to be the maximum temperature. Um, since it's a pull down thermistor circuit, it's going to be open circuited if you're reading high temperature like that. So anyways, I went and checked it, and I had 5 volts going to it, and then I jumpered the pin and went back to the live data on the scan tool, and it said negative 40 degrees or something like that. So I knew that the sensor was bad. So I ordered a sensor, and next day it came in, and I went back and put that in there, and finally got that code to go away, and then found out it had, oh yeah, I put a number 4 glow plug in it as well. It was bad. So I got all the engine codes out of it. And then I started working on the transmission, and that's where we get into a whole plethora. Well, not really a plethora. I had one problem that just kept reoccurring, and I'll explain that to you. Real good with sandpaper. Okay. O-ring's not sticking out the bottom of it. That's a good thing. Sure is hard to keep anything clean on this filthy beast. Okay. Cleaned out. Get the head gasket and sit it on here. Alright, back with the voiceover. I'll explain the rest of my Duramax LMM Allison transmission troubles here after a little bit. But I'm just explaining here that you can orientate that head gasket the wrong direction and put it on backwards. It's pretty hard to do it. I mean, you'd really have to be trying, I think, to do it backwards. But it'll go on the little oil feed where that feeds the rockers there. They kind of act as a dowel too. But then your coolant jackets and none of that stuff will line up. So it is possible to do it, but I mean, it'd be pretty. You'd really not be paying attention if you did that. On these 3208s, there was an earlier style head bolt, and I think I showed that here, and a later style head bolt. And we have the later style. I think the early style had 6 hash marks on them, and the later style had 7 hash marks on the head of the bolt. But if you're using new head bolts and you're torquing those down, there's actually a couple more steps to the procedure. I think you torque them in sequence to 110 plus or minus foot-pounds, and then you back them off, and then you do it again, then you back them off, and then you torque them. There's 3 more sequences after that. So yeah, you go. But see, we've got the old. We're reusing the head bolts. There's nothing wrong with them, and we're starting out at step number, like, I think 3 is what we started out. And we started out at 60 plus or minus 5 foot-pounds. Then we go to 110 plus or minus 5 foot-pounds in sequence, and then we do 110 plus or minus 5 again, and then you do tighten the 3/8 bolts up on the outside on the intake side of the head, and then you tighten those down to 32 plus or minus 5 foot-pounds.
You'll see the little 3 here. You go down to the note. Not necessary to do this unless cylinder block or cylinder head bolts are new. So these first 2 steps, if you're using new head bolts, which I'm not, do these first 2. So I'm starting here on number 3. Tighten bolts 1 through to 18 in sequence, 60 plus or minus 10 foot-pounds. So we're going to 65 foot-pounds. Let's see if I can get my camera set in the spot. Maybe that might be halfway decent. Everything about this job is not very much fun. It is what it is. It's what we signed up for. Alright, torque zeroing. I don't need torque zeroing. Let's go to 65 foot-pounds. Alright, where's our sequence at? Basically, probably start in the middle. Oh, okay. Let me put this over here and I'll just kind of... I don't get screwed up here. Okay, that's the intake side. So there, you know, we're going to start. It doesn't really... We'll start here at 1. This will be 1. Okay. This can be number 2. I should have grabbed a chrome socket. And the wind blew my paper. And we can make this here number 3. Thought I had those run down a little more than that. Now what's going on here? Oh, that's right.
Well, I thought during this torquing of the sequence and the audio fading out would be a good time to explain to you. Well, what I'm doing here is kind of start out in the middle there on the first 2 head bolts, and I'm having a hard time because I don't usually. They're showing the picture of the head as if you're standing on the outside of the truck or whatever looking at it. Well, I'm in the middle of the thing looking at it upside down, so I'm getting all screwed up. But basically, you just start in the middle and work your way out, and we have the later style head bolts on this one, so we go to the higher we go to the higher torque sequence, which is 110 plus or minus 5 foot-pounds. And then we started out on step number 3 because the first 2 steps are as if you're using new head bolts, and you tighten those down to 110 plus or minus foot-pounds. The first step, you loosen it up if you have new head bolts, and then you do it again, and then you loosen them up, and then you do step number 3, which is where we started out because we're not using new head bolts, we're reusing head bolts. So we're starting at it at basically a 60 plus or minus 5 foot-pounds. And then as step number 3, then we go to step number 4, which is 110 plus or minus 5 foot-pounds, and then we go to step number 5, and we do the 110 plus or minus 5 foot-pounds again, and then step number 6 is the 4 3/8 bolts on the outside, on the intake side of the cylinder head, and we start in the middle and work our way out, and those are 32 plus or minus 5 foot-pounds. So yeah, I'm sitting there kind of all screwed up because I'm looking at everything upside down, so... But anyway, I wanted to explain what I know guys are telling me, why don't you just put a reman transmission in that Duramax? Well, I'm bullheaded and I like to learn things, and sometimes I get frustrated when I'm having to learn things the hard way. But anyways, that's just taking parts out and putting new parts in. I don't learn anything how things work. I don't know, and I'm just kind of hard-headed. So sometimes to my own detriment, but that's okay. Anyways, I went through this transmission. We got it in there. You've got a pressure switch manifold on these, kind of like a 4L60E or a 4L80E automatic on this Allison 1000 series transmission. Well, 3 of those switches are normally open switches. That means that when they're open, there's no continuity between there and ground, and when they're closed, they have continuity ground, which sends a signal back to the transmission control module that tells the transmission control module there's oil pressure on that associated switch. So On this one here, every time that I put oh, and I should explain the shift solenoids and the shift valves. Okay, so there's, with those 3 normally open switches for the forward range switches, there's actually 3 shift valves associated with that. Okay, so, and then there's 3 shift solenoids to de-stroke. Those shift solenoids, the purpose of those is to exhaust the fluid and de-stroke the shift valve. The shift valve is got a spring on one end of it, and the spring is actually going to de-stroke the valve. So the oil pressure from the shift solenoid, well, from the line pressure is going to move the shift valve, um, moves the shift valve against spring tension. So with a shift solenoid actually cycles to de-stroke the oil from the shift valve, and then the spring takes over and de-strokes the valve, and then that makes the switch go to open circuit. So that being said, what happened is I got this thing started, and as soon as I put it in drive, it keeps saying shift solenoid 3 stuck on, and I can monitor in my live data on my scan tool. I can monitor the 3 normally open switches. I can monitor the command from to the shift solenoids 1 through 3. And what it's doing is I can go into drive, and it's supposed to command number 3 shift solenoid off, which it's doing. The transmission control module is commanding the shift solenoid off, but you can watch the actual pressure switch manifold, that's associated switch, which is number 3, and it always stays on. And then you can clear the code and then go back in there. What it's doing is the shift valve sticking. So I can go in there and you can go through this entire procedure of how to test this thing. I mean, it's quite of a lengthy procedure. So if the thing is, I found out a few things. So what you can do is drop the pan, and you can actually take the pressure switch manifold, leave it plugged in, and then the pressure switch manifold has a kind of a part of the case is kind of metal on it, and you can take a alligator clip ground wire, and I just grounded it to the case after I unbolted it from the transmission and let it hang there off the plug. And you can take a blunt object and go into the membranes there for those switches there, and take your scan tool, leave it plugged into the data link connector, and drag it underneath the pickup, and you can push those switches one at a time and see if they're all working. And that kind of verifies everything all at once right there. That verifies the power going to it, that verifies the ground, that almost pretty much verifies the transmission control module seeing what it's supposed to see. And actually there's a lot more steps on the OEM troubleshooting tree, but that step right there pretty much verifies everything. That verifies the pressure switch manifold's working, that verifies the wiring, that verifies the power and everything, it verifies the control module. I mean, they want you to do a whole bunch of other stuff that's kind of pointless when you can just do that. So I did that, and I verified all that was working, and I knew it was a shift valve. So I dropped the valve body down, and sure as heck, I popped it. I took a screwdriver in there, past where the plug is on the end of the valve, and you could feel it unstick and pop back over. So I took the valve body completely apart, and I took one of those bench buddy drills with a brush on it, and I went back and forth, and I put the valve in there where it would just, slide in on its own weight and slide to the bottom of the bore. And it took me several tries, but I finally thought I had it. And I actually stuck it in, and it didn't do it for, before it would do it as soon as you stuck it in drive, it would stick the valve. It would say shift solenoid 3 stuck on. So this time it took like 5 or 6 different cycles. I could go in reverse and back the truck up in the shop, and I could go drive and it'd be fine. I could do that 3 or 4 times, and finally about the 4th time it stuck it again. So I got on the internet and I found I was either going to buy another valve body and stick on it, or you can actually take a resizing tool, and Sonex comes out with a resizing tool to resize the valve bore to get it back to where it's supposed to be. And I'm not sure if the spool comes with it or not, but you can stick the spool back in there, and then it comes with a stiffer spring, so when the oil's exhausted from the shift solenoid, the spring takes over, and that spring's supposed to be stiffer and have a higher spring rate, and return that valve back to where it's supposed to be. so to de-stroke it. So I thought I would just explain to that. I thought it was kind of a neat thing to figure out. But if you guys are running on one of those, just hang in there. These automatic transmissions, I mean, the guys that do these for a living every day, I don't know how they have any hair left on their head.
Ding dong, you got it backwards. Nowhere to put your feet here. Wrong button. I'm gonna have to do something here. Damn it. Grab this thing in. Let's get a bolt. That'd be nice if I'd have brought him up here. Just got a couple rags in the intake now. To keep her from. Socket somewhere. Too carried away with that. This chain off of it. Okay. Chain off. Head bolts in it. Start going over the wonderful torque procedure. Well, I'm going to tell you guys the truth. What happened? I had to pull this head back off. Didn't take me very long. That plastic water neck, I was trying to get the new one in and it broke on me. I had it lubed up and everything and it just would not go in. I struggled with it for half an hour and I had it about 3/4 of the way in and it was going in, and pushed on it a little hard and it snapped. So clean one of the old steel ones up and put back in there, and I was gonna just use both steel ones, but I damaged the one. Get the head sitting down flat, and then I'm gonna try to work that goofy thing in.
Alright guys, I'm just showing you here the on the other side I broke the plastic one, the new one, and I actually had one still good used steel one that I stuck in there. So it's not the first time I broke one of those plastic ones. Anyways, I'm showing you here the actual the torque sequence on these heads, because yeah, you start there in the middle there at 1 and 2 and just kind of work your way out. I think that the work kind of gets goofy there as you get to like number 7, and then they skip a couple and they go clear to the ends on the torque sequence. Yeah, if you're following the torque, it's kind of weird, but anyways, usually if you buy the head gasket with these things, guys, it's the paper, the special instructions right there, the torque sequence and everything. Just follow along with what the special instructions for the cat head gasket says. I'm not sure if the aftermarket ones, I was going to buy aftermarket head gaskets, but that's the bad thing about it being over here where we're at. Aftermarket stuff is fine. A lot of it, I use a lot of it, but if I'm in a hurry, I don't want to wait a week for it to get here, because I end up paying about as much to get it here in a hurry and ship it if I want to get it the next day than I would have just buying it OEM. So that's kind of the reason I didn't go aftermarket head gaskets on this, because I didn't want to wait a week, because I kind of want to get this thing running and get it sold.
I might come back tomorrow, and I might just come back Monday. We'll see, and try to get this thing finished up. I got both heads on, intake on, air throttle on, fuel lines hooked up. I wind up taking that darn intake manifold back off of there. I don't know if I can get this fuel line. I kind of put the cart before the horse there on that. That fuel line needs to go up there on that and then go back around to here. But I might mess with it and tomorrow or Monday and see if I can get it. Hopefully I don't have to pull that back off, and then put the rockers on, adjust the valve. It just takes so long on this one because just everything, you're just down in this hole. It's just a real pain. I hope the owner understands that.